Good morning, good afternoon, good evening. Today we have a question here I would like us to look at. The question is this: which of the following represents the ratio of the hypotenuse to the given side? Now we have a 45, 45, 90-degree triangle here. If you look well, you'll find out the angles are 45, and we have another 45 and then 90 degrees in this triangle. This is a special type of triangle. Now I've used a brown highlight to paint the area that represents the hypotenuse. So that the line I have painted with brown, where we have 4 root 2, is the hypotenuse. And the line I have painted or I have highlighted with green, where we have 4, is the given side. So they asked us to find the ratio of the hypotenuse to the given side. So the hypotenuse is 4 root 2 and the given side is 4. Okay, now quickly, I want to attach something to the question so that it's easy for us to understand. So there's a note beside this. A 45 degree to 45 degree to 90 degrees triangle has sides in the ratio 1 is to 1 is to root 2, which follows immediately from the Pythagorean theorem. Now 90 degrees faces the hypotenuse. Let me use a highlighter to show that. So I'm going to use red for that, and I'm just going to this 90 degrees. I'm going to follow it. Sorry, that didn't go well. So I'm going to try and follow it, and this is where it goes. So the 90 degrees faces the hypotenuse. That's where it faces, and for the 45 degrees faces either the opposite or the adjacent. But in this case, it's going to be the opposite we'll be looking at because what we're given is 4. So let me use another color to show that. Let me use blue. And for 45 degrees, I'm going to try and trace this for this purple actually. And you see this. So the 45 degrees actually faces 4. So something like this will help, right? Make something makeshift. Okay. All right. So now I've been able to explain what I wrote here, where I said 90 degrees faces the hypotenuse. I've showed you it faces the hypotenuse 4 root 2, and 45 degrees faces either the adjacent or the opposite. But in this case, it's going to be the opposite because 4 is what 45 degrees faces, and that's the opposite. So it faces the opposite in this case. Now, having seen that, looking at this question already, if you are going by the 45 is to 45 is to 90 degrees triangle, 45 actually the first 45 actually is represented by 1 in this ratio. The other 45 is represented by this other 1 in the ratio, and finally the 90 degrees is represented by this root 2 that I'm just highlighting. So let me repeat that. Let me use color to show it. So highlight the 90 degrees. It's represented by root 2. Let me use purple to show what the 41st for this other 45. So this other 45 degrees, it's represented by 1. And finally, let me use green. This first 45 degrees is equally represented by 1. So that's how it goes. So looking at this, if you're trying to find the ratio of the hypotenuse to the given side, the hypotenuse 90 degrees is represented by root 2, and the opposite 45 degrees is represented by 1. So that means, as I've said here, thus the ratio of the hypotenuse to the given side is root 2 over 1. That's root 2 is to 1. That's what the ratio will be. So we are checking it now. Now if you check it, if you use what you have, hypotenuse over opposite, the hypotenuse is 4 root 2. So we have here, it's 4 root 2. So we have here, so we write 4 root 2 here, highlighting it. And the opposite is 4, as we have in the triangle. So I'm highlighting the 4. So that's why we're doing 4 root 2 over 4. Now this 4 is going to, the 4 in the numerator is going to divide the 4 in the denominator. That leaves us with root 2 over 1. The same thing that we got if you just look at the question. So that's why I've come out here to write this root 2, this right here, root 2 to 1 as the ratio. Because if you solve it, you're still going to get root 2 is to 1. If you look at it just using the ratio given to us, you're still going to get root 2 is to 1. So what we are going to do, look, I think what gives us that answer is A. So I'm going to highlight A as the answer. So that's that for this question. So if you see something like this, especially when you have a 45 to 45, 90 degrees special triangle, and they want you to find the length of a given side or the ratio of sides, you should know how to do that now. There are other triangles like the 60, 60, 60 degrees triangle. That's an equilateral triangle, and other special triangles. You can check those out and find out what the ratio of the sides are and know how to find the individual sides quickly without wasting time. So that's all for today. I hope to see you soon. Thank you.